We've had a very, very exciting day on campus with all of our wonderful friends from IBM. I've really had a really interesting and just a really kind of fun day. It's nice when you work with a group where you kind of have fun. And today, now at 4 o'clock, is our capstone to the whole day from Irvin. As you can see, Irvin Vidalski-Berger, he's the Chairman Emeritus of the IBM Academy of Technology. He has a visiting professor appointment at MIT. And he is also an adjunct professor at Imperial College. And we had a very, very entertaining lunch with Irvin, telling us some of his new thoughts on healthcare especially, which he may share with us today again, and in the general field of energy management. And we really look forward to a really vibrant strategic relationship going forward with IBM, with CITRIS, and some new ideas that we have with joint faculty and a really vibrant strategic partnership. Also here today, by the way, we have our colleagues from the other CITRIS campuses. Pat Manti is there, if you could raise your hand, and Dean Jeff Wright from the UC Merced campus, and his colleague Herman Gavalian. And so we have a real big CITRIS group here. I especially wanted to thank Jean-Paul Jacobs for setting up this whole day and working with Eric Gabrielson. And we have a surprise for you later. And you don't know what that is. So, no, they can't leave. So, it's nothing embarrassing, don't worry. And so, without further ado, I'd like to welcome Irvin to the stage, and let's give him a warm round of applause to get the thing going. It might be better to turn you on.
Okay, I think, oh, I'm on.
See, they did it to you as well.
Yeah.
I don't know why.
So it's a pleasure to be here, and we did indeed, as Paul said, had a very, very nice day today. So I'm going to talk a bit about innovation, a subject so vast that you can say so many things about it. So let me share some thoughts about innovation. And as you know, it's everywhere. Every business has a big innovation initiative. Every nation has had their own version of a national innovation initiative. The US had it in 2004. Probably Tom Friedman crystallized the moment in the world is flat almost more than anybody else. And it's always very interesting to step back and wonder, why is there such interest in innovation at this particular point in time? And let me give you a historical view of why I think there is so much interest now. And to do that, let me talk about the view that Venezuelan economist Carlota Perez has written about in her book, Technological Revolutions and Financial Capital, and has been writing about, which is that every major technology-based revolution, and according to Carlota, there have been 5 in the last 200 years or so, has 2 main periods. One is the period of installation, she calls it, where the technology is being developed. It starts out in the laboratory, then it reaches the marketplace, it gets bigger and bigger and bigger, eventually it becomes ubiquitous, the financial communities discover it, they go bananas, they start shifting money from older industries to the new technologies. They overshift, huge expectations, you get a bubble, it bursts. And then after things settle down, you get what she calls the period of deployment. And in the period of deployment, the technology is already under control. It's been developed here, And what happens during the period of technology is that it becomes integrated into every single aspect of business and society. And clearly, when it's in this period, the innovation is about the technology. Very interesting, but very focused. When you move to this period here, the innovation is in every single industry, every single institution of society, our personal lives, and not surprisingly, when you start entering this period, there's just going to be a massive amount of activity. And according to Carlota, we all pretty much agree with that, who've studied her work, we are around here, beginning the transition toward deployment. Let me give you an example from history. If you look back at the early 20th century, as you know, there was a massive amount of work in designing cars. That was a huge technology-based revolution, and it went on and on and on. There were a large number of car companies. As you know, eventually we had the big crash of 1929 and so on. But after that, the automobiles, while there continued to be a lot of innovation around the automobiles, look at all the industries that got built around the automobile. And look at how the automobile changed society, including the rise of the suburbs, interstate highways, vacation trips, trucking, and everything else that wasn't happening otherwise. And of course, this innovation was enabled by the automobile, but it was far bigger than the cars themselves. Now, as we know with information technology, the progress has been enormous. I don't need to spend any time talking about it. The prices have dropped at least as fast, which is wonderful for consumers and not so nice for companies like IBM that continue to be in the hardware business. It's very tough when every year you start the year having to sell 30-40% more of what you sold the year before just to stay even. That's life in the hardware technology business. We know about the internet, we know about open standards. So IT has experienced so incredible advances that it's almost boring to talk about it as it should. If we are in the deployment period of IT, then to spend a lot of time talking about IT is no longer interesting. So let me look briefly at how all these advances in IT have influenced the world of systems, of computer systems, and how they have influenced the way IT has become integrated into business and society. Let me spend a little time discussing that. Now, if you look at the period from about the 60s, 70s, 80s, that's when computers really started coming into their own. We had data centers, we had mainframes, we had mini computers. It was the beginning of networks. Needless to say, everything totally proprietary. And if you look at how IT was used in business in those days, because it was so proprietary, very few people outside the business had access to the machines. Later on, when networks started advancing more, ATMs started to show up for very limited applications. for the most part, the people using IT were within the business through proprietary terminals. And of course, before that, it was people like me, when I was getting my degree in Chicago, that would take deck of cards and walk them into the computation center and go have a pizza in Uno's, because it took a few hours before the job would run. Now, in the 80s and 90s, we saw the advent of personal computers. We saw the advent of local area networks, of client-server computing, and that caused a very big expansion in the use of IT, primarily within the business. PCs and client-server enabled the business to have a lot more people within the business have access to the machines. Still, not too many customers could use it for a very simple reason, because since it wasn't open, in order to be able to access the information or applications in the back office of the business, you needed to have a proprietary access to the machine, and not too many people had that. Then, as we all know, we had a massive disruptive innovation, the Internet, World Wide Web, and what we in IBM then called the business, and it began to change everything. And it began to change everything, first of all, because as a result of the rise of standards, for the first time, you can begin to connect everybody, and everybody including your clients. And you can make it much easier for businesses to connect to each other. You truly could begin to think of the notion of the end-to-end enterprise. And for the first time, not only could you have the classic back office applications, payrolls and inventories and banking and things like that, but because of the web, you could start building front office applications, customer service. Remember, that didn't exist before. Track your own package, go buy your own stuff. So it's very important to keep in mind that until the Internet, IT was primarily a back office technology. Very, very nice, but back office, and it's only when the web came in that it hit the front office, and through it, of course, you could start now linking to absolutely everybody, including the customers. Now, over the last 5 years or so, we've had what I can only describe as just a series of disruptive innovations, one more interesting than the other. And they've kept coming and coming and coming, and some of them are technology-based, petaflop supercomputers, cloud computing just showed up the last few months, I guess. And of course, some of them are much more business-oriented. The notion of globalization, global integrated enterprises, the flat world that Tom Friedman so much popularized, and on and on and on. And where this is all heading is that everything is now a system, absolutely everything. Not only are we looking to integrate all aspects of a business or any other organization, but because every business has an ecosystem, it makes no sense to integrate the business if you also don't integrate every industry in its ecosystems. So you have to integrate the whole ecosystem of that industry. And because more and more and think of healthcare as an example, in economies, more and more organizations are confluence of ecosystems. You know, you have the insurance companies, doctors, hospitals, governments, pharmaceuticals, all more or less dealing with each other. We are truly developing an integrated digital economy. Moreover, beyond integrating the technology, which we continue to work very hard to do, we now want to integrate the basic elements that comprise a business or an organization, namely all of its processes, all of its information sources, and most important, all of its people. This is a big deal. Sometimes we say, gee, why does it take so long to make progress? Well, you know, when you're trying to integrate the whole bloody economy around the world, don't be surprised if it takes a little while to go get there. We were in the panel before, we were wondering, well, what has it taken 5 years to get sensors to start working with other things? You know, this is not easy. Complexity is complex. And where we are right now is that as a result of all the advances, we truly are looking at absolutely develop the whole notion of IT-based global integrated businesses or organizations. In fact, I would say, that's why I highlighted here, the probably biggest next step over the internet that we've started to work on over the last several years have been to integrate people. That's why Web 2.0, social networks, collaboration have become so incredibly prominent. So there is an incredible amount that we can do with IT, but even more important, and I believe the real reason there is so much attention to innovation, what we are really looking at is how do we take all these advances in technology and integrate them much deeper, and in the process transform every single aspect of business, every single aspect of society, our personal lives, so that we can make them much better than they are now. That's sort of where we are. Now, is this easy? I would say this is the opposite of easy. This is god-awfully complicated. That's why sometimes when I hear people say, you know, there is no more room to be a technologist, an engineer, or everything else, all jobs are moving overseas, the answer is, give me a bloody break. There is probably no career more interesting than to be involved in making these things happen. So the amount of work for decades to come is going to be huge. And let me talk about now by focusing on 3 critical challenges to make this evolution of systems happen. Now, let me start by posing the question, if we truly are developing these global integrated business and organizational systems, who develops them? How do they get developed? I mean, that's not an unreasonable question. If we were having a talk about building an airplane or a car or something, somebody would say, well, Irving, so how the hell do we build it? So how the hell do we develop such business systems? Now, what's so interesting is, I don't think that's a normal question that we ask. We sort of, I think, assume that, well, you know, they sort of self-develop, that organizations, business, they sort of, you just put it together and they grow, and they grow. Well, that's not bad, but this is what it leads to. And by the way, this is a typical slide that we often have shown in IBM, one of our clients, and this is just part of one of their applications. And the technology is giving us the ability to do incredible things. However, the state of the art of the tools, processes, methodologies we have to deal with the technology is way behind, but way, way, way behind. That's why so much of the work of building these applications and business solutions continues to be done by hand. Not a good situation. And even if somebody said, well, but thank God there are, 1 billion people in China and another 1 billion in India, and then we have Russia, Brazil, and so on. As you know, that's not a way to deal with massive complexity, to just keep throwing bodies at it. So what do we need to do? Well, actually what we need to do is not very complicated, because we've seen this movie before. And I would say every discipline that for a long time was sort of a craft where you learn how to do it by working with the master craftsman, eventually they were not able to keep scaling. Somebody can say, well, there were a lot of cathedrals that were built in the Middle Ages. That wasn't bad. But as people may remind you, the ones we see are the ones that didn't fall down. And I'm sure a lot of them fell down. People learned how to build bridges, but eventually you couldn't keep scaling the way you build bridges. I remember when I joined IBM in 1970 in Yorktown, people would talk about these incredible mathematicians that knew how to do wiring things in their head. I don't think anybody can design a chip in their head. So clearly, the approaches of applying this sort of artsy, craftsy approach to building things only is good up to a certain point, and eventually things have to become much more of an engineering discipline. And as we know, when you do that, as we see very quickly in this example in building airplanes, you start applying technology and discipline, tools, processes, methodologies, and all kinds of capabilities to be able to get your arms around the very complex things that you're doing. And so you have to do that with first deciding what it is that you want to build. Once you decide that, then of course you design the plane, and you use, as you know, very sophisticated CAD tools, modeling, simulations of all sorts, and on and on. Then you use the CAM part of CAD, and you release it to manufacturing. Again, massive amounts of technologies, all very disciplined. And then, of course, it all goes back in operations and maintenance. And as we all know, whether this is a microprocessor or something in civil engineering or an airplane or a car, over the last 50 years, maybe longer, these things have honed in. That's what you learn when you learn engineering. How do you apply this very rigorous thinking to these very complex things that you want to build? Well, it's time for business and organizations to now make the transition from being a craft or an art or whatever they are to something where we need to apply a lot more discipline. And it's time because now we have more and more technologies to go apply to them. And once more, we have to look at a business or an organization as a system and begin to apply this kind of disciplined thinking in all stages, from how do you decide what to do, to designing it. I mean, businesses and their processes have to be designed if you want them to work. And more, especially as we apply these technologies to critical areas like healthcare processes, they have to work. And if you want them to work without failures, you have to be able to simulate and test. There's just no other way around it. And then, of course, you have to apply them very disciplined approaches to implementations, in particular, the use of standards and modular components. And then finally, you need to figure out how to operate and work with them. So one of the critical challenges is how do we bring everything that we have learned in other engineering disciplines to the world of business and organizational systems. But it's actually much more complicated than that, because these business and organizational systems, by their very nature, which we'll talk now, have to be far more flexible and adaptive than physically engineered systems. So the challenge ahead of us is even harder. Why is that? Well, if you sort of look at what goes on into a business systems, you can start down into the basic technologies, then you build hardware and software products with the technology, then you apply applications, and then finally you architect the business and you do it as a system. And I like to use this pictorial for the stack to sort of reflect the number of jobs that I see in the marketplace at each level. Just to remind anyone who says there are no jobs in IT, that the question is, it depends where you look. If you look at the areas that are older, more standardized, and more commoditized, for these jobs, there won't be a lot. And if you want to be a microprocessor designer, you better hit 350 or higher. That's just the way it is. However, and in fact, the more the areas down here standardize and commoditize, the more applications you can build, the more sophisticated the business systems, and that generates tremendous requirements for jobs. If I look at IBM, and as you know, we have a lot of wonderful laboratories, but I would say only 15% of our technical people are in labs. The rest are up the stack. And I think remember, an IBM still a very technology-based company with a lot of laboratories. For the vast majority of the world, all the jobs are moving up the stack. What happens is that when you're doing things primarily involving technology, products, machines, you're dealing with back office systems. Whereas when you're working at the levels of applications and business systems, you're dealing with the market-facing part of these systems. Now, a business system needs both. It needs, obviously, back-office systems, as we saw in the first section, and it needs market-facing systems. But they are very different in nature. The back office systems tend to be very repetitive. Transactions. They do the same thing pretty much every time. They are pretty much standardized. They are deterministic. If you're going to design something, it's really nice that whatever you're designing knows its place. And when you design it, it stays put. It doesn't keep changing. Market-facing systems are emergent. They are unpredictable. They keep changing all the time. So the notion of designing a market-facing system, or let me say it a better way, designing the market-facing portions of systems is very, very different than designing the back-office portions of systems. And why, pray, are market-facing systems unpredictable? It's a very easy answer, because market-facing systems consist of people. That's the world of services, of people doing things for each other. And I don't know if you have noticed, people are totally unpredictable. And if you are going to be designing systems to be used by people, boy, those systems better be flexible and adaptive. Otherwise, they'll be bad systems. And by the way, we have a lot of bad systems out there, because a lot of systems being used in business, like, pick your favorite legacy ERP system. Those are vintage the late 1980s, when the biggest advances in IT was relational databases. So, SAP R3, it's wide use, but they are from the vintage of relational databases, and the world has advanced a lot in the last 20 years, but those systems haven't quite gotten re-architected to become much more flexible and adaptive. And as a result of that is why you have the massive infusion of labor, because we're trying to make up for the rigidity of the systems with labor. That's what we are doing. We are sort of adding lots of people to try to sort of make the systems do what their intrinsic architecture does not let them do. And of course, as we all know, just about all of our educational system continues to be focused on classic engineering. Very, very important. We need to keep having people who are good at doing classic engineering, but especially since there may be 2-3 orders of magnitude more jobs up there, it would be nice to start educating people who are more comfortable in this world of people-oriented market-facing systems, which is what we've been calling services sciences. I don't think it's any more complicated than that. I know a lot of definitions what services. It's involved people and it's up the stack. And that feels like is that a fair definition, Jim?
Yeah.
And it is emergent, unpredictable. That's another huge characteristic. Now, about a year ago, we had a workshop on complex systems at the NSF, and we focused on 3 classes of systems, which was very interesting, how we looked at complex systems. At one end were physically engineered systems. At the other end were biological systems. And as you know, biological systems have to be flexible and adaptive, otherwise evolution does them in. It cannot survive. And what's so interesting about these human organizational systems is they are really in between. They clearly have characteristics of physically engineered systems. At the very least, they are engineered. And, you know, unless you believe in intelligent design, nobody views biological systems as being engineered in that sense. But, like biological systems, they must have the ability to evolve. They just have to have it, because a business or an organization that cannot evolve will die. And by the way, Adam Smith, the marketplace, is absolutely happy with dead businesses as long as new ones are born in their place. And as we know, the world is full of dying businesses that are feeding the new growing businesses around them. I mean, marketplace could care less as long as the overall marketplace is healthy. So that's not so good if you are one of those dying businesses. I mean, it's really not a pretty picture to be sort of a carcass for new ventures to steal your market share on. That's not fun. And what this really leads to is that whenever we think of this cycle of business systems, you're never through designing. I don't know how else to say it. You decide what to do, you design, you build, you operate, you get feedback from your operations, and you're back to the drawing board. This is just, you're constantly designing and evolving the business, and your architecture and your tools and your processes have to have these kinds of qualities, which different from sort of the classic engineering we've grown up with. The last point I want to discuss is how do we humanize these increasingly complex systems that we are hopefully designing. Now, why do we need to humanize them? In case anybody asks, I don't need to tell you that we are all drowning in information and technology, and here we are at UC Berkeley, where we shouldn't be drowning. Let alone, more and more, these kinds of technologies are going everywhere, into cars and hospitals, people's homes, and those people have to deal with it. And so we need to do something. When you really ask yourself the question, why are these systems so complicated to use, I think it helps to remember that the last major advance in user interfaces was probably the GUI, the graphical user interface, which was developed at PARC in the late 1970s. Remember, even browsers are pretty much GUI-based. That was the last major advance. So here we are, and look at how the rest of technology, of digital technologies, have advanced since the late 1970s, in the last 25, 30 years. And the way we try to use it is by wrapping these GUIs around them. That is why so many of us have gotten so excited when we saw perhaps the most exciting new innovation in user interfaces coming up through the world of highly visual immersive games and massively multiplayer online games and environments. And as you know, these are very, very, very different. And so we're asking ourselves the question now, could this be the answer to this conundrum we have, that we have all this technology, all this innovation, but the interface cannot stop at the glass. It has to stop at somebody's brain. So remember, it's critical to get the information into your brain in the most natural way you can. And you know, our brains happen to be wired for sight and sound, and we like interactive things, and that's why these things have started to come up. So maybe this is truly sort of the broadband way to get into our brains as opposed to the narrowband ways we've been using. Now, anybody who's been involved in supercomputing should say, well, this is not new, because we've been using visualization in scientific and engineering computing at least for the last 20 years, if not longer. But of course, the huge difference is that supercomputing visualization has been very, very expensive. And only people who could afford the supercomputers or the high-end workstations required for that visualization could use it, whereas with these games, it's a box that costs a few $100s with the game players or a normal PC that now can handle this. And of course, the same thing with engineering. We've been using it in design. So I think that one of the most fascinating frontiers in how to humanize the interfaces is to look at this whole virtual worlds and highly immersive interfaces and see how it works. And at IBM, as you know, we've started a lot of work in these areas in a variety of places. I'm convinced, by the way, that the initial killer apps here will be education and training and collaboration and meetings. Those are the initial killer apps. Why is that? Because that's what people are doing out there. If you look at what goes on in Second Life, in social networks, even in World of Warcraft, people hang out. They do things with each other. So they're either collaborating in meeting or more and more, as we're doing in IBM, is that Jacobs Hall? Yeah. In Jacobs Hall in Almaden's Virtual Island, we schedule for courses. And we're also beginning to experiment with commerce, but I think that's a little bit farther ahead. The real challenge with applying virtual worlds to everything is that, remember, if you're going to design the interface that you want the humans to use, you want to design the interface that reflects the way they think about the application. So you have to get into their brains. And then we get into, okay, that's easy if you say colliding galaxies. Well, it's a goddamn colliding galaxy. That's how you do scientific visualization. Or if you want to do crash simulations, you show the crash simulating. But how does a hospital administrator think about their hospital? How does a nurse in the hospital think about the hospital or the patients she has to deal with? How do the doctors think about it? Remember, when you're simulating, there are many lenses at which to go at the same problem. It's like physics. Sometimes it's a wave, sometimes it's a particle. So you can take, for the same problem, different points of view, but the real breakthrough is to extract from the people that you want to use this how they think about it, and then present to them whatever application you're presenting to them in that form. I think what it means is we have to introduce design back into engineering, which at top schools like Berkeley and MIT, I think sort of the envy of physics kicked it out maybe 20, 30 years ago, when most engineers say, I want to be really a physicist and just do math. Whereas now, we need to do a tremendous amount of real creative design to figure out how to do that. And not just the engineers. We need now everybody to jump in the wagon here to help us understand what are the interfaces that will better capture this stuff. I mean, right now, with the kinds of virtual stores we can build, I mean, we can make this store be anything. So where are the master merchandising engineers that would give us the most fabulous, I don't know, bookstore imaginable that will just look like you go into it and you say, oh my God, this is incredible. Those things have to be developed, and I think they will happen. But let me just close by summarizing. We are absolutely in a massive transition from the industrial economy that focused on machines, technologies, products, and back office kinds of things, to a knowledge economy that focuses on markets and people and all the things that make them tick. The nature of innovation to attack these problems in the knowledge economy is totally changing. You need to innovate in technologies, products, and services, but increasingly you need to innovate in business processes, business models, culture, and everything else. And finally, our role in universities is to develop the multidimensional leaders that are very good at dealing with complex systems because of their technical education, at complex markets because of their business skills, and with complex organizations because of our people skills. That's the challenge ahead of us. Thank you.
Thank you. We have time for some questions. And I'll pass the microphone around.
Yes.
Oh, Gary has got that.
Can you say something about the challenges posed by security issues? Certainly we hear more and more about identity theft and data theft. It doesn't seem to be getting any better, and particularly, you know, if things evolve into better human interface, you want to make it easier to access these systems, and yet you've still got to worry about the security issues. So to what extent do you think security will act as a brake, or will these issues be solved to a greater extent? And
yeah, well, we obviously have to address security and privacy and other issues, and that becomes a key reason why having well-behaved architectures. You know, remember, a lot of the security problems is because when you have spaghetti code, and I don't mean I'm not alleging any desktop operating system as suffering from spaghetti code, but when you have that, you've lost control of your design. I mean, if Boeing did the airplanes like that, they'd be crashing right and left because there is no way to do that. I think that having well-layered, well-designed, highly standardized modular systems will help a lot. Now we have to add the correct security, we have to build in strong encryption, all those things have to happen, but they have to be architected in. I don't think they sort of get added after the fact where, you know, normal human beings have to deal with semantic firewalls. Now, Semantic is a fine company, and you know, John Thompson is a wonderful CEO, but you know, normal humans shouldn't have to worry about that because they probably have no idea what it is, other than somebody told them use this, and then it keeps talking back to them, and they don't know what's going on. I mean, that is a poorly designed system. I don't know how else to say that. And we have to stop facing up to that. That's a poorly designed. I mean, if that was a BMW, they'd be out of business. So I think we need to make a lot of progress, but it all gets back to good design. And those things are really badly designed.
Your question over there, boss. There's the mic. Over there.
I thought there was another one over there. That's
Oh, Dave, is it you?
Tom doesn't get to ask
Well,
questions?
he does, but we're going in.
Okay, okay.
I liked your picture showing the spectrum from physically engineered systems to biologically engineered systems, if you like. But we do deny the likelihood of intelligent design. So we have to face the fact that biologically engineered systems proceeded just the way you said, by evolution and survival of the fittest. Now, it strikes me that that's the way we're going with our other kinds of systems in the middle now. That AT&T used to define the telephone system, and it was a very completely integrated picture. But what's happening, all the innovation these days seems to be coming from new directions based on people doing all kinds of mashups, taking that term in a very general sense. And shouldn't we just face that as a reality and sort of try to construct our paths for the future in our different individual and organizational forms, recognizing it?
No, I agree that we need to take that into account, but it should be possible to keep defining layers of design below which you don't want anybody messing up, you don't want mashups, you want things that work the way they should, and above them you can have a free-for-all. And in a dynamic system, those boundaries will keep shifting. That is, they will keep going up, but there is no excuse for having a free-for-all up and down the layers, because that's where you get into security violations and hacking and all that, because it's a free-for-all. You know, by the way, notice I never said this was easy. In fact, what I said is, isn't it wonderful to be an engineer or whatever the hell one needs to be to do this, a systems person. I mean, sort of, I think of it as a systems person because that can include a business systems person, not just a classic engineer. And you need to think this through this is really problem solving at its best. But in many ways, a lot of what needs to be done because of the market-facing nature is bring back design, bring back that point. And I think it should be possible to find the right boundaries to do what you're saying. Although the problem with just saying, well, it's evolution, let it go, evolution takes a long time. And thank God also the invisible hand will not tolerate that, because people will have wonderful ideas. They'll have companies that do some new things that all of a sudden make it all much better. So hopefully that will drive it.
Tom Khalil has the next question. One of your slides, you talked about computer systems.
By the way, we need massive R&D. So if you are connected to anyone who cares about that, tell them we need massive R&D to do this.
Okay, Irving.
The first step is for everybody to vote the right way.
So
I wasn't taking any political position.
One of the slides you talked about computer-assisted business systems, and by analogy, you could think about CATIA and Synopsys and Cadence and all these other tools that we have. Is this totally an aspiration on your part?
I think,
or are we beginning to develop things that point in that direction?
I think it's beginning to happen. In IBM, there's a massive amount of work in tools like Rational and so on. But remember, the architecture is critical here. CATIA wouldn't work if there weren't standard components to build the airplane or car. It just wouldn't work. So we need far more standard modular components in how we build the systems in order for the tools to be able to do their thing. Now, locally, that's the direction SOA is taking us. And in fact, part of one of our talks today was the critical importance of web services to be able to connect the pieces. And beyond that, we need standards at the industry level. I mean, for example, we need to go, when I say we, I mean hopefully, students getting PhDs and so on, to hospitals and find out, why do you do things the way you do it? And why do you do it in this hospital different from this other hospital? They'll say, I don't know, because that's the way it's been done. Well, but MRSA is not good. That's the superbug infection. And what does it have to do with MRSA? Well, that what we've learned from discipline-engineered systems is that you can get a handle on quality. And you can apply measurements and so on and take them down. But if you don't have a handle, if everybody does it totally differently, if Berkeley, if you were going to give masters in healthcare systems, in healthcare engineered systems, and every goddamn hospital does it its own way. Some people wash their hands, some people don't wash their hands, some people don't care. That's not good. In a fab line, everybody has to wear the goddamn bunny suit. You don't have a choice. Say, well, my hair will get messed up. You don't go into the fab line.
I don't have that problem. So we're going to the final question over here. I'm sorry. Oh, I should say we're having a very nice reception outside afterwards. So for those of you that don't get a chance to ask a question right now, please come to the reception. But we do have to wrap up with our last and final question here.
Right,
Thank
you for coming. I think it's clear that IT holds a lot of promise for driving improvement in healthcare, as you've begun to allude to. But at the same time, investment by the industry in IT is far lagged behind other industries. Clearly, there are some barriers to adoption as far as standards and interoperability, that kind of thing. What do you see as ways to get around that, and specifically sort of thinking around open source? Is that a model that can help us bridge this gap?
That's definitely a model, but let me tell you just, and this is not a political commercial, but as, for example, in MIT, we've been trying to put together, it's another good engineering school, we've been trying to put together some systems projects to go attack healthcare, like MIT did very good work in manufacturing 15 years ago or so. Who funds that? Remember, universities need money, and NIH funds a lot of medical research, all important, cure cancer and find out how the brain works, all that. But medical research is totally different from healthcare delivery. It turns out nobody funds it. I mean, there are little places here and there, and I don't know, what's healthcare? $1 trillion? I don't know how big the economy is. So, DOD might be a great source of funding because they have a massive problem. And in the old days, of course, DARPA would say, great, we'll step up to the plate. Now they wouldn't do that. But I think we need a massive R&D attack. And by the way, the money goes to the universities, not to anyone else, because that's how universities then put the right programs in place. And this takes research. This is just hard work. I don't know how else to say it. There are no easy answers here. This is really, really, really hard work, one process at a time almost, because you just have to attack the problems. They can be attacked. The technologies are there to do something, but you have to attack it organizationally and politically as well as technically.
So you can see, this is a man with great passion for the future. It's just a wonderful talk. Thank you so much. Would you join me in a round of applause? Before we adjourn, I now have another delightful task. I think when I gave the introduction, I might have used a word like congenial or fun or some, whatever we had today with IBM and CITRIS. It was just a really wonderful day. And I'd like to thank all of our colleagues. I can see 4 sitting right there, and then the rest are scattered around. A very special thank you, though, would come to Mark Dean. And Mark, would you be kind enough to join me on stage just for a second? We have a plaque for you with great warmth from us to you. And it reads on this plaque, for his commitment to establishing a congenial, there's that word again, and productive, which we're going to do, relationship with CITRIS, and we express our heartfelt gratitude to Mark, who's our IBM Fellow and the Senior Location Executive for Silicon Valley, and Vice President of the IBM Almondon Research Center in San Jose, California. And this is signed by both myself and Gary on behalf of also Shankar, and previous to Shankar Rujna. And Mark knows many of these people. He's been a luminary in this relationship, and it's just a wonderful moment. Let me put down this thing. And then I think there's some sort of special way.
A photo moment?
We can shake hands.
No.
You weren't expecting
No.
Well, that's the best kind of gift.
Right. Thank you. Thank you. This is really for IBM. Thank you, John Paul, the IBM team. I'll accept it on your behalf.
That's good. Thank you. One more thing. Eric, would you like to come forward, please, too? So also in these golden boxes, sometimes you'll see the Berkeley faculty ex-deans in particular, though David is now much more informal in his response. We have these wonderful golden bears that I enjoy wearing on my lapel from time to time. And the colleagues that I'd like to honor very much with these are Eric Abelson, who's really worked hard with Gary and Laurie. There's Laurie over there, and Yvette. And they've really spent, as you can imagine, the last 2 months of working with us to really get this event organized well. And so I hope that along with your IBM pin, you will wear this with great happiness. So thank you. Oh, sorry. Thank you. Thank you, Eric. That's good. And then, as you know, the person that really made this happen with his love and dedication and many, many 2 o'clock in the morning emails is our good friend, Jean Paul. And since he has really been the leader in this program, I really want to sincerely thank him for this. He hasn't quite got a little television. And with that, I think it's time for us to have a little wine and a little refreshment. Gary, am I missing anything? It's right next door. Please join us. Please join us for some more congenial activity.